One of our last lessons in geometry is going to be symmetry. Now, I think most of you are pretty comfortable with symmetry, but we're going to go over a little bit more in depth than you've probably had before. I bet a lot of you have seen pictures where you have a half of a picture and you need to draw the exact other half, right? That's like symmetry. Symmetry connects with our congruence that we had yesterday in that movement. We talk about a reflection, right? Reflection is where you see something back, the exact same image, right? And today we're going to go over lines of symmetry, right? Here are a bunch of shapes. There they are. Right? Whoops, not those shapes, those shapes. Okay. When we talk about lines of symmetry, that means that we can put a line on a shape and fold that shape in half on that line so that we get two exact matching congruent figures, right? And on each of these shapes that I have here on this screen, we're going to look at lines of symmetry and how many lines of symmetry a shape can actually have, because a shape can have one line of symmetry, or it can have many lines of symmetry, or it can have no lines of symmetry. So when we make a shape and draw a line of symmetry, that means we want to be able to take that shape and fold it over on that line so we have two exact matching halves, or two congruent figures. Okay, so let's start with this square and let's draw a line of symmetry someplace where I can draw a line across the shape and fold it in half. Okay, so I'm going to start with one right here, pretty much in the middle. I'm going to go as close as I can. Okay, this is one line of symmetry. That means I can fold this bottom half up onto this and I get two exact congruent figures. Now that's one line of symmetry. The square happens to have another line of symmetry going straight down this way. Okay? That's our second line of symmetry. I can fold this half over this half and I have two congruent figures. I actually have two. I take a square, fold it in half, and I have two rectangles. Now, is that all? No, that's not all. A square has another line of symmetry. We go from corner, as close as I can here, corner to corner. I can fold this side over onto this side, and I will have two triangles, two congruent triangles. That is a line of symmetry. And if I can draw a line of symmetry in these angles on these corners here, I bet I could draw one on these corners here. I can. I can fold this half over onto this half, and I will have a line of symmetry as well. So on this square, I don't have one or two or three. I actually have four lines of symmetry on this shape. So I'm going to write that right here. I have four lines of symmetry on that shape. Come on, move up for me. There we go. Okay. What about this shape? This, let's see, let me go down to the star, okay? The star. How many lines of symmetry does the star have? This one is pretty interesting. I hope I have black here. Yep. The star. Well, let's start here. I can draw a line straight down on this star from this point, or this vertex, that vertex right there. And if I fold it in half, the sides will match. So that's one line of symmetry. Well, believe it or not, I can do the same thing for each one of these vertices and draw it straight across here. That's two. And that's three, as close as I can get here. And that's four. There we go. And one more, five. So this particular star has five lines of symmetry. So I'm going to put a five down here to show that it has 5 lines of symmetry. All right, let's go over here to this triangle. How many lines of symmetry do you think the triangle has? I bet most of you think it has 1 line of symmetry. Well, it does have 1 line of symmetry. I can draw a line straight down here. And I'm going to scoot that over just a little bit because it bugs me. There we go. But that's not the only line of symmetry on this particular triangle. This triangle is an equilateral triangle. Remember, all 3 sides are equal, same size, so we call it equilateral. This triangle has a line of symmetry here as well. And it has a line of symmetry here as well. Notice when I do that, all of these lines intersect at one point. So this triangle, an equilateral triangle, happens to have 3 lines of symmetry. So we'll put a 3. I think this is going to be a big 3. There we go. This one has 3 lines of symmetry. Move yourself up, please. Come on, Mr. Lines of Symmetry. Let's move up. No, I guess I need to do that. You don't want to hide it down there, right? Okay, so now let's go to our rectangle. Now, similar to the square, I can go across the center this way. And these 2 sides are congruent. And I can go down the center like this. And these sides, 2 sides are congruent. So those 2 lines of symmetry. But can I go from corner to corner on a rectangle? I cannot. It doesn't work on a rectangle because if I take this corner and fold it up, it's going to come over here. So this only has 2. A rectangle has 2 lines of symmetry. 2. Right? So let's go to this parallelogram now and try the parallelogram. Okay? Well, can I draw a line across this parallelogram like this? Again, I'm going to slip that down a little bit to make it kind of in the slide it down. Come on, you slide down a little bit. There we go. Does it look like I can fold this up? Let's see. If I take this corner and I fold it straight up, guess what? It's going to go here. And if I take this corner and I fold it straight down, it's going to go here. Will they match? No, they're not going to match. So I need to get rid of those lines. That is not a line of symmetry. That won't work. So let's get rid of this. That is not a line of symmetry. So can I draw a line of symmetry straight down on my parallelogram? A vertical line of symmetry, even if I move it over. So it's sort of in, well, I can't because it looks like it's in the middle here, but it's not in the middle of there. That is not a line of symmetry. It does not work on our parallelogram, on this particular parallelogram. Now, if you look closely, you'll notice it's also a rhombus. Now, what about this? Can I go from corner and corner and I draw a diagonal line? I can. Does that mean I can do it this way too? Guess what? I can. So in this particular parallelogram, which is a rhombus, I can draw 2 lines of symmetry on this particular one. So this one has 2 lines of symmetry. Right? Now I saved the circle for last because a circle, I can draw a line here, and I can draw a line here, and I can draw a line here, and I can draw a line here. So now we're at 4. But guess what? I can also draw one here we're at 5, we're here, 6, we're here, 7, we're here, 8, we're here, 9. Guess what? I could do this forever and ever and ever. So how many lines of symmetry does a circle have? It has an infinite number of lines of symmetry. This number, infinite. That means never ending. We could go on and on and on and on. Make it a little bit bigger. So a circle has an infinite number of lines of symmetry. There we go. But does every shape have lines of symmetry? Let's take a look at these. What about these shapes? Do these have lines of symmetry? Is there any place that I could draw a line, divide this shape in half, and have two congruent figures? Well, maybe here. Let's try here. In this particular triangle, I cannot. If I take this edge here, this vertex here, and I pull it straight across, it's going to go over here. It's not going to meet this. If I take this and I pull it straight across this line, it's going to go over here. That's not going to work. Nope. Guess what? This triangle, this scalene triangle, because no sides are the same, this scalene triangle has 0 lines of symmetry. What about this speech bubble? Is there any place in this speech bubble that I could draw a line and have two congruent figures, make it a symmetrical figure? Nope. This one also has no lines of symmetry. Now, what about this parallelogram? Now, if we think back to the parallelogram over here, which is also a rhombus, it had 2 lines of symmetry. Does that mean this one has 2 lines of symmetry? The same way, can I draw a line of symmetry from corner to corner and from corner to corner? Well, let's see. I'm going to go back here. Let's change it to red. If I take this corner and I fold it straight across, guess what? It's going here. If I take this corner and I fold it straight across, whoops, almost it's going here. They will not match up. A parallelogram does not have angled diagonal lines of symmetry. Nope, it's not going to work, so I need to get rid of those. So can I draw a line of symmetry going straight across? Well, it didn't work for the rhombus in the other parallelogram, so it's not going to work for this one either. Nope, because if I draw a line here and I go straight across, it's going to end up here. And if I go this one and I go straight, pull it in half, it's going to end up there. Nope, that's not going to work. This shape also has 0 lines of symmetry. 0, none. Okay, so not every shape has a line of symmetry. What about some figures, some shapes of objects? What do you think? Do these shapes have lines of symmetry? Now, let's ignore some of the pictures on here. We're just going to look at the shape itself on this one. This one, does it have a horizontal line of symmetry? Can I take this and I fold this in half? Nope, it's not going to work because we've got this cylinder up here, so that's not going to work. That is not a line of symmetry. But can I take this line of symmetry and put it straight in the center? I can. This one would work, right? I cut this right in half. I have 2 symmetric figures, right? How about our can of baked beans? Does that have a line of symmetry? Let's take this. What if I put it right in half? If this were a can of beans, yep, I could take the bottom and fold the bottom on top and have it be symmetrical or 2 congruent figures. What about a vertical line? Yes, There are 2 lines of symmetry on this one. Now let's look at this tool. If I take a vertical line, can I fold it in half on this line and get the same shape on both sides? Same size, same shape, pretty congruent? Nope, doesn't work that way. But does it work this way? If I draw a line straight through the center of this particular shape, make this go a little bit longer and stretch it this way. Yes, I have one line of symmetry. Let's look at this sandcastle. Do you think it has a line of symmetry? Well, let's try my horizontal line of symmetry. No, I don't want that. There we go. Can I draw a line this way? No, come on. There we go. Does that work? No, that doesn't work. What about a vertical line of symmetry? Does that work? We have a problem. I have a flag on top. And the flag is not exactly the same on both sides. So this one does not have any lines of symmetry. It won't work. Nope. Let's try this door. Now think of the door with everything that it has on it. And I will see if I have a line of symmetry here. Does this half exactly match this half? It doesn't, because there's a door handle here and that's not over here. So that's not going to work. It does not have a line of symmetry that way. What about a line of symmetry this way? It doesn't look like my windows match up. So no, this doesn't have a line of symmetry either. Now what about the car the way it is? Can I draw a line this way? Oops. Again, we're not going to be cooperating. There we go. Will my top and bottom match? Nah, not even close, you guys. What about this way? Will they match? No, not even close. So no lines of symmetry on that figure. Whoops. Didn't mean to do that. I meant to do that. And last but not least, what about this brush? Can I draw a line of symmetry on my brush? It goes this way? No, because this doesn't match here. So that's not a line of symmetry. What about this way? No, they don't match at all. Those are not reflections of each side, so that doesn't match, right? So some shapes will have a line of symmetry and some will not have a line of symmetry. Let's see what I have here. We're not going to take a look at those. If I was in class, we do those, but we're not. Okay. So I think you, for the most part, most of you, from what I saw on the pretest, lines of symmetry was pretty easy for most of you. There is a video, a song from Number Rock, Symmetry song, for you to watch next on the wall. So go down below this instructional video and watch and listen to the song. It's got some great pictures of an amusement park and how you see symmetry there. Right? And then go to your assignment in your on your assignment page. You will find the assignment for today from chapter 11. Now this is going to be our last lesson in geometry. We're going to do a quick review, and then we are going to have a test on chapters 10 and 11 coming up. Okay, check out your assignment.